Okay, so we were talking about which one was linear, which one was exponential. If you have a bamboo that grows quickly, model the scenario. So we need to talk about why this is linear. So let's look at what the change is. So how can we find that change? I'm going to use my calculator. How can I find the change? What operation can I do to find out how far apart they are? What'd you say? Yeah, subtraction. So which one do I subtract? Which one do I say first? 27.9 minus, okay, 4. Oh, no, I messed up. 0.2, there we go. 4.7. All right. Then let's check the next one. How do I find the next? Subtract 32.6 minus 27.9. So what operation is happening here? Adding. So I need to put a plus there. I forgot my plus. Okay, let's check the next one. 37.3 minus 32.6. So 4.7 again. Go here. 42 minus 37.3. 4.7. So how do we know that it is linear from this table? Okay, so it'd be a constant rate of change. And the operation here is plus 4.7. You need to have this out. This is what y'all should be working on. Put the other thing away, please. Okay, so we can write our sequence here. 23.2, 27.9, 32.6, 37.3, and 42. Then our recursive. What do we start with? 3.2. And then next equals new. What happens to, not new, it's supposed to be now, isn't it? Now plus 4.7. Okay, now how do we write our equation? For linear, what is the equation format? How do we write the equation? Yeah, mx plus b. And what does the m represent? Slope or rate. What does b represent? Y-intercept, which is also called what in this case? Yeah, the star. So then in this one, what is our rate? 4.7. And what is the start or the y-intercept? 23.2. So f of x is going to equal mx plus b. So 4.7 times x plus 23.2. So our last thing to do is graph it. So I want at least 3 points. So I'm going to do 1, 2, 3. So let's look at what our numbers are. The highest number that we're going to put is 37.3. So what should I count by here? 5s or 10s? Then I just have 10, 20, 30, 40. I think 5s would be good. 5, 10, 15, 20, 25, 30, 35, and 40. I should have did it like I did last week where I used the ruler so it'd be evenly spaced, but I forgot. But you can use your ruler to make them more evenly spaced. So our first one is at 23.2. Next one, 27.9. Next one, 32.6. Next one, 37. What should the graph look like? Should be a line. And go ahead and extend that line. Okay, how do y'all feel on linear? Good? All right, let's go to the next one. You put a hot 100 degrees Celsius cup of water in the freezer. The water cools. Model the scenario. So just think about this scenario. How do you think this graph is going to look? If the water starts out at 100, okay, so it's going to go down. So it's going to be a decrease, right? It's decreasing. All right, so we have this table right here. So let's look at it. So how would you know for sure that it's not linear?
Because they don't have the same constant.
Okay, so by subtracting, you can find that. So 100 minus 95 is 5. And it's going down. 90.25 minus 90. Oh, I should do it the other way.
That's a minus.
Oh, yeah, it's a minus 5. I should have done 95 minus 100. Negative 5. 90.25 minus 95. 85.74 minus 90.25. 81.45 minus 85.74. Okay, so it's not increasing by a constant rate. So that means that it's decreasing by an exponential rate. Okay, so how could we find what that exponential rate is? Remember for linear, we subtracted, we did this one minus that one. Divide. Because what usually happens is you do 100 times something to get that. Well, we need to find out what 100 times something that gets 95. So yeah, we need to do the opposite. So we need to do 95 divided by 100. 0.95. Yeah. How did you know that without even plugging it in the calculator?
Sorry, did it.
Because you already did it? Okay. 95 divided by 100. 0.95. Okay, so that means this is times 0.95. So then we need to do the same thing here. Do 90.25 divided by 95. Oh, it's the same. So that means that is times 0.95. Let's check the next one. 85.74 divided by 95. I did the wrong one, didn't I? 85.74 divided by 90.25. There we go. Okay, even though this has some other numbers here, what would that round to? Yep, 0.95. And let's check the last one. 81.45 divided by 85.74. Oh, what would that round to? 95 again. Times 0.95. So what does that mean our rate is? So let's say exponential rate is 0.95. So it's not 1. 1 would be the same, but it's a little below 1. So if it's a little below 1, what's happening to the temperature? If the exponential rate is less than 1, then your temperature is decreasing. So it's 95% of what it was. If we can write our sequence. Write your sequence. You already got that? Okay, and then we need our rule. What is the rule? What did we start with? 100. Times 0.95. So we know that this is exponential. What is the general equation look like? F of x equals B then the A? Let's see. We wrote it down on this. F of x equals A times B of x. That's our general form, where A is your starting point and B is your rate. So let's write that. A times B of x where B is the rate, A is the start or y-intercept. So then to write the equation, how would we write this?
100 times.
Yeah. Okay. How could we check both of these? Well, we haven't done the graph yet. Let's do the graph first. So I want at least 3. And then what should my y-axis go by? If I want 100 and I want to go down, so I need this to at least be 100. 20, 40, 60, 80, 100. So we start out at 100. Then, that's 1, 2, 3. I'm going to go down to 95. Go down to 90.25, 85, 81. I didn't do them exactly how they should have been. It should have been like that. So 1 was 95, 2 was 90.25, 3 was 85. So we know it's going to go down exponentially. So it's going to be like that. So let's put that in the calculator. 100 times 0.95 raised to the x power. All right, put this in your calculator. Sit up. I want to graph it. I don't see anything. What quadrant do we want to be in?
1.
Okay, so go to Zoom, quadrant 1. Still don't see anything. You need to have your calculator and you need to do this. So what is keeping me from seeing anything? Where does this go to?
100.
Yeah, it needs to go to 100. So how do I change that? Window. Okay, window. Which value do I change? Y max. Good. So I need to go up to 100. What should my scale be?
20.
Okay. I'm just going to keep everything else the same. Now hit graph and see if you can see it. Okay, it almost looks like a line, but is it a line? No, it's still tilted down, it's still a curve. Okay, why do you think this was called Let's Get Messy?
Talking about the bamboo.
Because it's messy.
What makes these problems more messy than what we...
Decimals.
Decimals, yeah. Decimals. Arr. Okay, so we're going to fold this in half and glue it in our journal.